Airloom Energy introduces a groundbreaking oval-shaped wind energy system that utilizes an oval track with vertical wings to generate power. The innovative design significantly reduces costs associated with wind power, using smaller components closer to the ground compared to traditional tall turbines. The system employs a cable-mounted oval track with smaller poles and 10-meter wing blades, promising easier transportation, construction, and maintenance. The cost estimation for a 2.5 MW Airloom system is substantially lower, less than 10%, compared to a regular turbine, aiming for an ALCO of around 1.3 cents per kilowatt-hour. Significantly cheaper than current wind energy costs. The technology aims to be visually less intrusive, scalable horizontally, and adaptable for various terrains, potentially expanding wind farm sites. Breakthrough Energy Ventures, led by Bill Gates, has invested in Airloom, supporting the potential of this disruptive wind energy solution. Despite promising cost reductions, there have been concerns about technical challenges and slow progress. Based on a Glassdoor review mentioning issues with the first prototype, researchers at Carnegie Mellon University developed a soft-bodied robotic replica of Prehistoric, a prehistoric marine organism that moved using a stem-like appendage. The robotic replica was designed based on fossils of Prehistoric and replicated its movements using a flexible motorized swishing stem. Testing revealed that wider sweeping movements of the stem propelled the robot forward efficiently, and increasing the stem's length improved speed without additional energy consumption. Insights from this robot could influence the design of future robots for efficient locomotion across sea floors or similar environments, providing valuable knowledge on ancient marine organisms' movement methods. The study, led by Professors Phil Leddick and Carmel Majidi, not only brings a historical creature to life, but also promises valuable learnings for robotics. Veer's shift drive is a belt drivetrain system for ebikes that allows shifting between two gears, and is compatible with traditional wheel hubs and frames. It features the split belt, a long strip riveted together to form a loop, allowing easy replacement when worn out, without needing a removable section in the bike frame. Unlike traditional belt drives limited to a single gear ratio, the shift drive incorporates a rear cog with swiveling sprocket-toothed elements that adjust independently, altering the engaged part of the cog for gear changes. The technology can work with third-party geared hubs, potentially doubling the available gears, and Veer plans to add more gears to the shift drive system. The shift drive is expected to be integrated into production ebikes and possibly other light electric vehicles, starting from the next summer in the Northern Hemisphere. Commercial partners can engage with Veer through their campaigner website. Sierra Space unveils its first Dream Chaser spaceplane, named Tenacity, designed to transport cargo to and from the International Space Station, ISS. Dream Chaser faced initial setbacks in competing for both cargo and passenger missions to the ISS, leading to improvements in its technology. Tenacity, the first flight-worthy craft, will undergo environmental testing at NASA's Neil A. Armstrong Test Facility, after being at Sierra Space's facility in Colorado. The spaceplane, equipped with wing design and propane nitrous oxide propulsion, is capable of autonomous re-entry into Earth's atmosphere, minimizing re-entry acceleration to 1.5 grams. Ideal for fragile cargo like pharmaceuticals and crystals. Scheduled to launch atop a United Launch Alliance Vulcan Centaur rocket from NASA's Kennedy Space Center in April 2024, it's set to offer services to both NASA and other domestic international customers. For low Earth orbit trips, Sierra Space CEO Tom Weiss emphasizes Dream Chaser's significance, describing it as a revolutionary product that redefines space travel, reflecting human spirit, determination, and exploration. Japanese scientists developed a novel plastic, VPR, based on an epoxy resin vitrimer infused with polyrodoxane. VPR exhibits exceptional properties. It can self-heal scratches when heated, remembers and reverts to its original shape, and degrades much faster than typical vitrimers. The plastic breaks down into its raw components upon heating with a specific solvent, enabling easy recycling. In seawater, VPR biodegrades by 25% in 30 days, releasing molecules beneficial as marine life food. Its durability, quick self-healing, recyclability, and marine-friendly breakdown make it versatile for various applications, including infrastructure and vehicle manufacturing. The Tyroler ring, made of titanium, serves as a portable measuring tool, enhancing the capabilities of everyday carry, EDC, multi-tools. It features a central wheel marked with metric or imperial scales that spins as the outer ring is rolled along a surface, displaying measurements through a small window. Each revolution produces a satisfying click, helping users keep track of distances measured, with the metric version clicking every 10 centimeters, and the imperial version every 5 inches. Its rolling design enables measuring of variously shaped objects, without the hassle of traditional tape measures, sharp and bendy metal strips. The sleek design allows it to be worn as a necklace or carried in a small leather pouch attached to a keyring. The Kickstarter campaign for the Tyroler has been highly successful, surpassing its initial goal by raising over $143,000, with pledges available for both metric and imperial versions.